Welcome to today's AR14 CS Digest for March 6, 2026. We received 673 new computer science papers today across 46 subfields. Let's dive into the top picks. Up next, our first paper out of 5, Accelerating Scientific Research with Gemini, Case Studies and Common Techniques by Google Research and Nanyang Technological University from Carnegie Mellon University. Let's break down its key contributions. The foundational contribution involves leveraging Google's advanced Gemini-based AI models, including Gemini DeepThink, as collaborative partners. This enables researchers to tackle open problems and generate novel proofs across various scientific domains. Up next, our second paper out of 5, Physical Simulator in the Loop Video Generation by Lin Gung Fu and Christian Theobald from Max Planck Institute for Informatics. Let's break down its key contributions. ArXiv first reconstructs the 4D scene and foreground object meshes from a template video. These reconstructed elements are then initialized within a physical simulator to prepare for dynamic simulation. The initialized physical simulator generates physically consistent trajectories for the objects. These simulated trajectories are crucial for guiding the subsequent video generator, ensuring spatiotemporally coherent motion in the output. To enhance texture consistency during object movement, ArXiv introduces TTCO. This technique adapts text and feature embeddings of the video generator, leveraging pixel correspondences derived from the physical simulator. Up next, our third paper out of 5, RMR1, Reward Modeling as Reasoning by Xiuxi Chen and Denghui Zhang from University of Illinois at Urbana-Champaign. Let's break down its key contributions. Introduces a new class of generative reward models, ReasRMs, which formulate reward modeling as a reasoning task. This approach enhances interpretability and performance by stimulating deep thinking before assigning a reward score. This core mechanism within RMR1 involves self-generating sample-level rubrics or solutions. It enables the model to evaluate candidate responses against these generated reasoning chains, providing structured and interpretable judgments. This initial training stage focuses on distilling high-quality reasoning chains. It involves learning from expert-generated or carefully curated reasoning examples, establishing a strong foundational understanding for the model's reasoning capabilities. This second training stage employs reinforcement learning, leveraging verifiable rewards. This phase refines the model's ability to generate accurate and interpretable reasoning, ensuring robust reward signals aligned with desired outcomes. Up next, our fourth paper out of 5, Knowing Without Acting, The Disentangled Geometry of Safety Mechanisms in Large Language Models by Jianman Wu and Xiaofeng Chen from Xidian University. Let's break down its key contributions. Up next, our fifth paper out of 5, Ambiguity Collapse by LLMs, A Taxonomy of Epistemic Risks by Shira Gioria and Sina Fazilpour from Harvard University. Let's break down its key contributions. This paper introduces ambiguity collapse, a phenomenon where LLMs resolve genuinely ambiguous terms into a singular interpretation. This bypasses human practices of meaning negotiation, leading to significant epistemic risks. A taxonomy is developed to categorize the epistemic risks of ambiguity collapse across 3 levels: process, output, and ecosystem. This framework helps understand how LLMs distort meaning and reshape interpretive norms. The paper illustrates the identified epistemic risks through 3 distinct case studies. These real-world examples demonstrate the practical implications and manifestations of ambiguity collapse in various LLM applications. Multi-layer mitigation principles are sketched to address ambiguity collapse, covering training, deployment design, interface affordances, and prompt management. These principles aim to design systems that responsibly surface and preserve ambiguity.